Hey guys, today we're going to talk about ions. There's a couple things that we need to talk about with it. We need to talk about how we form ions, along with what they're called when they're a positive or negative ion. We're also in this segment going to teach essentially crisscross is what it's called. It's a technique to actually form the compounds from these ions. So first, take notes as we go. Everything that I do, I'll do on the board for you guys. Feel free to take notes. So. Ions is what we're going to be working on. There's two different types of ions. Ions are formed from an atom losing or gaining an electron. If you remember, the electrons are on the outer shell, so it's easier for those electrons to move than the protons. Okay. So if we look at, let's look at an easy one. Let's look at sodium, for instance. Sodium is located right here. Sodium is the first one. If you recall sodium, sodium is Na. You may or may not remember this, but that's fine. The point of showing you this is showing you how many electrons there actually are to give away or receive. Give away in this case. So sodium's first shell, if you remember, is 1s. So 1s, 1 being the energy level, which is represented by the circle, has 2 electrons. That's the max that can have. On n equals 2, which is the second energy level, if you remember, there's 2s2 and 2p6. 2 plus 6 is 8. So the second energy level can hold 8 electrons. So some people show them spread out. It doesn't really matter how you do it. So that's sodium. With 10 electrons, but if you remember, sodium has 11 electrons. So the very last electron, if you remember, is in 3s1. The third energy level has 1 electron. Now, if we want to fulfill the octet, it's easier for us to give away an electron. It's easier for us to give away 1 electron than it is to actually gain 7 more electrons. So because it's easier for us to give away an electron, sodium will normally willingly give away an electron. When it gives away the electron, it's going to end up with a positive 1 charge, okay? Which we would write with sodium, positive 1. It's positive 1 because we have 1 more proton than we do electrons. We have 1 more proton than we do electrons. So that's where all this is coming from. Right now I'm going to show you which ones are positive 1, positive 2, so on and so forth, by looking at the periodic table. I'll try and write bigger. I see that. It's hard to see, so I'll write bigger. So here we go. So looking at the periodic table, everything in this first column, the alkali metals, are +1 when forming an ion. Everything in this column, +2. And then these transition metals we actually skip those right now. Those are called polyvalents, meaning that they have multiple charges or multiple oxidation states. So we're going to skip both this color and the heavy metals, okay? We're going to skip this color, transition metals, and the heavy metals as well. Let's look at these real quick, okay? +3, plus or minus 4, and then this will be -3, -2, -1, and this doesn't have a charge because these are always happy. These are your noble gases. They won't combine with anything. They're always happy. So let's look at it again. Remember, when you write these down, okay, these are the charges of these different groups. These are also known as oxidation numbers, okay? So +1, +2, skip. +3, this is for boron, and as you'll see here in a second, aluminum. So +3, plus or minus 4, -3, -2, -1, 0. Okay? Last 3 that I want to show you are these 3, silver, zinc, aluminum. You may or may not notice that these are listed on your things to memorize on your polyatomic ion sheet, even though they're not polyatomic ions. Silver is always going to be +1, zinc is always going to be +2, and aluminum is always going to be +3. Okay? plus 1, plus 2, and plus 3. Let's see how this looks when we try the crisscross method. Okay? Need an eraser? We're going to stop it. We'll do the crisscross method in the next video.